A very happy and a pleasant morning to you all children. Today we will be continuing the lesson which we have taken up last week, that is metals and non-metals. Children, what you are going to learn in this 8th standard about metals and non-metals are only basic. The detailed study of the same lesson, metals and non-metals, you will again incur when you come to class 10. So those equations which are given now, just go through it without much worry. So you will be learning about the equations only when you come to 9th standard. Just go through what is given here. I have given you the informations more than what is found in your textbook. Today we are especially going to discuss about the reaction of metals and non-metals. That means the chemical action of metals and non-metals. We are going to deal it in detail. So observe every slide with most careful so that you will get understand. Okay children, now we will pass on to the next slide. Children, carefully observe the two pictures which are given in this slide. The first one represents the burning of magnesium ribbon. Magnesium, as you all know, it is a metal. So when a piece of magnesium ribbon is introduced into the fire, and you can see how sparkling light it gives. So this we can demonstrate when you come to the normal class. It will resemble like the firings which you do in the time of Diwali, especially what you call Kambi Matapu. Right? This is the first illustrated diagram here. Secondly, you can see a iron chain is giving rusted irons are there, and you can see the brown color rust which is formed on the pieces of iron. Again, iron is a metal. So both of these are due to the reaction of metals with oxygen. Now let us discuss how these magnesium and iron are reacting with the oxygen in the next slides. Children, let us discuss the first experiment, the burning of magnesium ribbon, step by step in the tabular form. So this tabular column contains the experiment, observation, and what is the inference that we get out of the observation. First, magnesium ribbon is rubbed with sandpaper. So when you rub the ribbon with sandpaper, the dust particles and the oxide particles which are coated on it are getting removed. So the observation is it looks silvery white. So what is the inference? Color of the magnesium metal is silvery white. Then after that, second experiment, magnesium ribbon is burnt. So with the help of the tongs, right, as you are seen in the diagram. So what is the observation? It burns brilliantly and a white ash is left behind. So the solid magnesium ribbon burns brilliantly, and after burning it leaves a white ash. Okay, a white ash can be collected after burning. So what is the inference that we get from this? Magnesium burns in air to form magnesium oxide, that is MgO. So when magnesium is burnt in air, it takes up the oxygen from the air. Therefore, magnesium reacts with oxygen, and so what we get as ash is nothing but magnesium oxide, which is powdery in form. Then the last one. Moist red litmus is brought in contact with the ash of magnesium ribbon. So we have two litmus, red litmus and blue litmus, and the nature of the litmus is an acid will turn blue color to red color litmus. On the contradictory, a base will turn red litmus into blue litmus. So, to find whether the given liquid is an acid or base, we can use the litmus as a test paper. So, if the blue litmus changes into red, then it is acid. If the red litmus changes into blue, it is a base, right? Now, we have to take the moist litmus paper. That means we have to dip the litmus paper in water, and then we have to introduce in the ash which has been collected as magnesium oxide. Now, the red litmus paper turns blue. That means when the red litmus turns into blue, then it is basic in nature. That is what it is given in the inference. Magnesium oxide is basic in nature. Children, you find the concept in this. We are burning magnesium. Magnesium is a metal, right? And after it reacts with oxygen, the metal oxide is a base in nature. This is what you have to learn from this experiment. So, metallic oxides are basic in nature. So, this is a very good question which is frequently asked in the board examination. Show by an experiment that metallic oxides are basic in nature. So, this is the good experiment which you can write and get the full marks for that answer. Okay, children, you got it now, right? Magnesium ribbon burns in the air to form magnesium oxide. When the magnesium metal burns, it reacts with the oxygen found in the air to form magnesium oxide. Oxygen and magnesium combine in a chemical reaction to form this compound. After it burns, it forms a white powder of magnesium oxide, and the chemical reaction for this is 2 Mg plus O2 gives 2 MgO. Children, we are going to see the next illustrated diagram, which is rusting of iron. Rusting is nothing but it is called corrosion. Corrosion is nothing but eating of metals by another substance. So this corrosion can be found in three metals: iron, copper, and silver. So let us read the slide and understand each concept. Oxidation of iron is called as rusting. So rusting takes place because of oxidation. That is, the metal combining with oxygen is called oxidation. Rusting involves slow oxidation of iron in the presence of air and moisture. So the equation for this is 4Fe plus O2 gives 2 Fe2O3. This Fe2O3 is the chemical name of rusting, which is chemically called ferric oxide. Fe2O3 represents the chemical formula for rust. This 2Fe2O3 plus X2O, again it combines with water to give Fe2O3 with some molecules of H2O, right? This is what is called hydrated iron 3 oxide. So this equation, as I told you, you need not bother about much, but the chemical name of the rest you should be able to get it in your mind. Now let us see what is corrosion. The eating up of metals by the action of air, moisture, or a chemical on their surface is called corrosion. So as we have discussed, copper also undergoes corrosion. The copper objects lose their shine after some time due to the formation of copper oxide on them. When a copper object reacts with moist carbon dioxide, it loses its shiny brown surface and gain a green coat basic copper oxide, which is a mixture of copper carbonate and copper hydroxide. So when you don't use a copper vessel for a long time, you can see a green color coating on the surface of the inner side, which is nothing but due to corrosion. It reacts with the oxygen present in the outside, so it forms copper carbonate and copper hydroxide. Then we will go to silver. Silver articles become black after some time when exposed to air because it reacts with sulphur in air to form a coating of silver sulfate, right? So when you buy silver from the shop, any articles made up of silver from the shop, it will be very shiny, and when you go on using it, it becomes blackish in color. So the shining gets reduced and it gets deposited with a black color coating over it. This is nothing but due to the reaction of silver with the oxygen present outside. So these are the three metals, that is iron, copper and silver, the metals which undergo corrosion. And this corrosion is due to the reaction of metals with oxygen. Children, we are going to discuss about the reaction of metals in with water. So previously we had discussed about the reaction of metals with oxygen. Now we will discuss about the reaction of metals with oxygen. Some metals react with water to form metal hydroxide, whereas some of them do not react at all. Reactivity with water differs from metal to metal. Metals like sodium and potassium are highly reactive. They react with water to form alkalis such as sodium hydroxide and potassium hydroxide. The reaction is 2Na plus 2H2O gives 2NaOH plus H2, where NaOH is sodium hydroxide. Children, what you have to infer from this is metals react with water. Not all metals react with water. Certain metals react with water, cold water. Certain metals react with warm water. Certain metals react with steam. And there are metals which do not react with water at all. For example, if you dip the gold in water, nothing will happen to it. So there are some metals which do not react with water at all, but there are some metals which react vigorously with water. They are potassium and sodium. Sodium and potassium are the one which reacts even with cold water. So they catch fire immediately as soon as they react with water, right? The next is calcium. Calcium also reacts with water to form calcium hydroxide and hydrogen. So calcium Ca plus water H2O gives CaOH twice plus H2. CaOH twice is calcium hydroxide. Whereas magnesium and zinc do not react with cold water. They form their respective oxide when reacted with hot water. So here comes magnesium. It doesn't react with cold water at all, but it reacts with warm water. The equation is Mg plus H2O gives MgO plus H2. Next comes the last one, iron. Iron is less reactive than sodium, potassium, calcium, zinc and magnesium. It does not react with cold water and hot water, but it reacts with steam to form magnetic oxide. So the equation is being given here. So these are the reaction of metals with the water. So some react with cold water, some react with hot water, some react with steam, and many they do not react with water at all. Children, now we go to the new concept, reaction of metals with dilute acids. First, we have seen about reaction of metals with oxygen. Secondly, we had seen about the reaction of metals with water. Now, we are going to see about reaction of metals with dilute acids. What do you mean by dilute? Dilute means acid being added to water in excess of quantity. We call it as dilute acid. Dilute represents it is being diluted by water. So metals like sodium, potassium, lithium and calcium react vigorously with dilute hydrochloric acid HCl, H2SO4 sulfuric acid to form their metal salts and hydrogen. While magnesium, zinc, iron, tin and lead does not react vigorously with acids. So here is the equation. Mg plus HCl gives MgCl2 plus H2. Fe plus H2SO4 gives FeSO4 plus H2. Metals which fall below hydrogen in the reactivity series does not react with dilute acids. Children, this slide you need not bother much about it, but some of the metals react with acids to form their chlorides and sulfides. And this reactivity series you will learn when you go to your class 10. Right, children? Children, let us see an activity for the reaction of nonmetals. Here is an activity with sulfur. Take a small amount of powdered sulfur in a deflagrating spoon and heat it. If deflagrating spoon is not available, you may take a metallic cap of any bottle and wrap a metallic wire around it. You can see in the diagram a glass jar is being taken and a deflagrating spoon is taken and powdered sulfur is taken into the deflagrating spoon. Let us see what to do. Now let us continue the activity for sulfur. As soon as sulfur starts burning, introduce the spoon into a glass jar or glass tumbler. Cover the tumbler with a lid to ensure that the gas produced does not escape. Remove the spoon after some time. Add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Check the solution with red and blue litmus paper. Now let us analyze the result of this experiment which we have conducted so far. What we have done, we have taken a deflorating spoon and taken sulphur powder, and we have introduced it into the glass jar. Sulphur by nature, it reacts with air which is present in the jar, and so it gets reacted with the air, and so a compound called sulphur oxide is formed. So read the slide. The name of the product formed in the reaction of sulphur and oxygen is sulphur dioxide gas. So a gas is produced and the name of the gas produced is sulphur dioxide. When the sulphur dioxide is dissolved in water, sulphurous acid is formed. The reaction can be given as under: sulphur dioxide SO2 plus water H2O gives sulphurous acid H2SO3. The sulphurous acid turns blue litmus paper red. So we can conclude generally oxides of nonmetals are acidic in nature. Children, this slide gives you in a nutshell of the experiment we have conducted. Reaction with oxygen. Nonmetals react with oxygen to form non-metallic oxides. These oxides are acidic oxides because they react with water to form acid. Example, sulfur burns in air to form sulfur dioxide. Sulfur dioxide reacts with water to form sulphurous acid. S plus O2 gives SO2, SO2 plus H2O gives H2SO3, which is sulphurous acid. This slide especially gives the comparative study of all the properties which we have seen for metals and nonmetals, especially chemical properties. Reaction with oxygen. Metallic oxides are basic in nature. Oxides of nonmetal are acidic in nature. Then reaction with water. Metals react with water. The reaction may be vigorous in the case of sodium or slow in the case of iron. Nonmetals generally do not react with water, though they may be very reactive metals such as phosphorus. Reaction with acids. Metals generally react with acids and produce hydrogen gas. Nonmetals do not react with acids. Children, here are the major difference between metals and nonmetals on the basis of their chemical properties. First, oxides of metals are basic in nature. Oxides of nonmetals are acidic in nature. Second, metals displace hydrogen from dilute acids, whereas in the case of nonmetals, they cannot do so. Third point, metals form chlorides which are electrovalent or ionic compound. Nonmetals form chlorides which are covalent compounds. This electrovalent and covalent and ionic you will study in detail when you go to your class 10. Fourth point, they displace hydrogen from water. They do not or cannot do so. So these are the four major differences which can be given on the basis of chemical properties of metals and non-metals. Children, and that's all for today's class, and now we come to an end of today's class. Today we have especially discussed about the chemical properties of metals and non-metals with air, with water and with acids. Now learn the concepts well, and as I told you, the equations you need not struggle so much. You will automatically learn when you come to your class 10. Now understand the concept, and after you post your response, I will ask you orally some questions in order to test your understanding. Therefore, when you post your comment, seen or watched the video, then I will begin to question you. Therefore, before you post your response, be thorough with the concepts. And by next week, we will be completing this chapter, right? So we will meet next week. Until then, bye from you children. Have a good day and be safe at your home.